So today you will get an overview of my control. It's a CNC machine, so I built up a user interface panel. Before I will close the box, I like to show you the inside of the box. Afterwards, at the end of the video, I will add a few pictures how I did the construction of the mechanics and so on. But now let's look inside. So I will lift it up a bit. So here is the front panel. Below there's a keyboard, emergency stop and so on, some analog inputs, on button to power on the complete machine light and PC and so on. So let's start with the inputs. I place the inputs here on the top of the panel. We have here the power line, 230 volt AC. We have one separated cable for the analog inputs to the Mesa card. We have one bigger wire. It's 30 times 0.5 square millimeters. Here are the most of the control buttons included. It looks a bit wild here, but here are the 30 wires connected to most of the functionalities here. For example, the emergency button takes 6 wires, so you need a higher wire count if you like to connect a lot of buttons. Here there are 3 network cables with RJ45 connectors. So one cable, the green one, is for the handwheel. So it's possible to connect a handwheel. Here below there's a outlet, and I build up I'm still building up the handwheel of Thaler. So thanks also to Peter in this way for supplying me a PCB card and also the microcontroller already programmed. That was pretty nice to get this support, because I have no programmer for microchip. So the only thing I did is I print up the enclosure with a 3D printer of Tom, and I put it together like the tutorial of Peter. Okay, the last thing what is missing is the connection cable here with this LAN connector. I can later supply here, and then I have the connection to the green cable to my main switch cabinet. Okay, so this was the green cable. Here the white one is the connection to the Mesa card later. It's connected from the included Ethernet card of the PC. And the magenta one, this is for having internet connection or LAN connection to the local area network. This is done by a second external Ethernet card. It's connected via USB, and it's the type, if you like to know, I'm not sure, can you see it? It's UE300, and it's recognized by the Debian Linux system. So it's easy to use without additional drivers. Okay. This buttons. It's a complete system where you can buy some discrete normally open contacts and normally closed contacts, and also some LED lamps if you like. to show the status of the switch on the front panel. They're available in different colors, so you have to choose if you like to buy a green LED, red one, or white one, for example. Okay, let's have a look to the computer unit. I bought a used Ilyama ProLight 19-inch touch monitor. The touch monitor has a resistive touch with 5 wires. So resistive touch, I think it's impossible that you are not using some capacitive touch or whatever, because the resistive touch, you need a force on the display that will do a reaction. With capacitive touch and, for example, liquids and so on, you may have some input errors, and it could be dangerous when you're using it with a machine. Okay, so I dismounted everything on the monitor, and the monitor was split in 2 parts. On the rear side there was the controller of the monitor, so it was not connected to the front panel, or not assembled to the front panel. So because of this, I created here this metal part, the sheet metal, and I was then able to mount this, and also to keep the HMI shielding here close to the panel, between these 2 parts. Okay, for the computer I chose Fujitsu. It's a Q956 MP3 computer. So this was something I bought very cheap on eBay, and for this reason, or for this application, I think it's totally okay. I put it here on a few stands to keep the airflow working, and for the on-off button, when it's in the enclosure, it's not accessible anymore. So I will enable in the BIOS, I will enable the boot on power up. So then I have the option here on the front button, where I showed you on the beginning. This is the button for the PC on. So this directly switches 230 volt AC power, and then the AC is coming here to the monitor, and at the same time the PC is powered up. Okay, so in addition I put a light to get feedback if the PC current is enabled or not. So you have to be a bit careful. These connectors, it's written that they are current limited. I think it was 6 amp for contact, so you have to put a fuse before. For example, when you are connecting here a standard plug, which can be connected to a socket of 16 amps. So this is not really safe. So for this reason, after I was going in here with my cable, I put a fuse in the line with around 5 amps. So this current has to be lower than the current which can be conducted by the switch. So I would say this should be now enough for the inside. One more. I put a fan inside. I'm not sure if the heat dissipation is too big from the computer and the monitor side, that I will stress the components inside. So I decided to put a fan on it. Therefore, I created here some 3D printed parts as air outlet and also air inlet. Here it's a outlet, it's on the top, later on the top of the housing, because the hot air is going up, and then I will blow it out here at this position. And for the inside, I have it on the bottom side, and here on the bottom side I still have to mount my inlet filter. So it's just a sponge I will put in, and then I will screw it to avoid some dust getting in. This is also the reason why I try to keep the housing as sealed as possible. Here, for example, the front panel, I also added a sponge to get it more or less sealed. Okay, I used a 24 volt fan. Usually when you are connecting it directly to 24 volt, it's getting pretty loud. So to avoid this, I added a few resistors in series to apply a voltage of finally about 12 volt, and so the noise is acceptable, and it should be okay for the airflow. Okay. Here on the side, here's one handheld. I think it's nice when you are watching the monitor later to put a hand on it, and with the other hand you can make some inputs and actions on the controls. Here on the side there are a few USB ports which can be used. So there are different types. I got two USB 3 I don't know, 0.1 or 0.2 ports, and one USB 2 port. So I think I can take my CNC programs, my G-code on a USB drive and put it in here. Or maybe I will create a backup, whatever, of the complete PC with external drive. It's very useful. So also with dust protected covers. Okay. Yeah, for the monitor, the original monitor has a few inputs. I put below on the bottom side of the enclosure, so I'm still able to have access to the monitor functions. Here on the right and left of the bottoms, there still is a thread where I can where I will print out a 3D cover, to also make it as sealed as possible and avoid some dust coming into the buttons. Okay, later for the mountings, I will do the mountings on this side here. Here are two M6 screws, and on the bottom side also. So yeah, I put a L steel inside to apply a bit more stability in the sheet metal housing. So now I will put everything together. I will add the front to the bottom. See you. 20 screws later, the enclosure is closed and finished. I used here the black screws to have an indicator. If you like to reopen it again, you just have to unscrew the black ones all around. So here on the bottom side I also mounted the air inlet with the sponge behind as a filter. Here on the bottom side, as I already told you, it's a monitor control which will be closed later. Here it's a connection for the hand wheel. By the way, doing the 20 screws I also quickly finished the hand wheel. I closed it, just the labels are missing for now. Here you will select X, Y, Z axis. Here's the scale of the encoder. Here, for example, you can start and stop the machine, and whatever. Here you can maybe 0 on the tool. Okay, here I've got the RJ45 jacket. You can put in there now, and then you have a handwheel control with the encoder. Okay, here on the right side, the USB outlets, 2 times USB 3, 1 time USB 2. The handheld, the fan behind here, connection on top, and here some mounting positionings, maybe for a hinge or whatever. I don't know what I would choose, but I have the option to mount it here. Okay, by the way, I connected the 230 volt power grid. Here this cable is now connected, so let's give it a try if the PC will start. So I switched on, and the monitor already starts up. So now the keyboard is also starting, so this PC should run now. Actually, there's no feedback of the button because the 24 volts are missing, and this will be established when it's connected to the main cabinet. So these putties I bought from AliExpress. These are cheap ones for $1 or $2 each. The buttons are original ones from Eaton, but I bought in used conditions. So okay, I have to log in. CNC. Let's run Linux CNC. Yeah, here it looks like this. So for now it's ready. We will see later on the machine if everything works well with the buttons, and maybe there are some connection errors or whatever I have to solve, and I hope I will get everything to work here in this region. It's my first machine here with Linux CNC. I only did a machine before with Mach 3, and I also tried Mach 4, but I think it will work. Okay, maybe as a conclusion, what I would do a bit different next time is the size of the panel here. It's very big, so it's approx 550 multiplied by 550, and the height is about 100 millimeter. So this is also because of the monitor. It has 19 inch. So if I would do it again, I would decrease the monitor size to, let's say, 17 inch, and put the buttons more together to compromise it a bit. But it's okay now. Maybe it's also nice when you are touching, but yeah, it's a big thing. Okay, so now the pictures are following. Yeah, have a nice day, and see you next time.